Alright, so this podcast is on applying the systems of equations. In this case, using them to solve word problems. So they won't give you the equations. You're going to have to read the problem and write your two equations. And then from there, you're going to solve it. You can solve it by graphing, you can solve it by substitution, or by elimination. Okay, but the setup is kind of the hard part here. Okay, so here's the steps. First thing you want to do is to highlight or underline the important information. It's going to help you write the two equations, right? You just want to focus on the important information. Next, define your variables. What does each variable represent or stand for? Then you're going to write the two equations using the variables. You're going to solve them, and you can choose your method. If you like substitution, use that. If you like elimination, use that. And then check your answer. Okay? And then answer the question in a real-world problem, meaning what is it referring to? Okay? Alright, so let's try this here. So number one. Number one says the sum of two numbers is 34 and their difference is 14. Find each of the numbers. Alright, so remember the first step is to highlight the important information. So what's important here is the sum of the two numbers is 34. Right? Remember sum means adding and their difference is 14, means subtracting. That's the most important thing. So I'm going to use two variables and we have to define them. So if we think about it, we'll just call x, that will be the first number, and then we'll call y the second number, because we're talking about two numbers, right? So now we're going to write this system of equations. We're going to write two equations based on the word problem, okay? So the first equation is going to be this. The sum of two numbers is 34. So remember, sum means add, and I'm adding these two mystery numbers. Remember, is your equal sign. So the first equation will be x plus y equals 34. That's showing that the sum of the two numbers is 34. Now this is going to be the second equation. The difference. Difference means subtract. Is my equals. So the difference of these two is 14. So this will be x minus y equals 14. Alright, this is my system of equations now. Alright, now once again, you can use substitution or elimination. Okay, you can stick with whatever way you like the best. I like to look at the problem because some problems, one way is easier than the other. Hopefully you're noticing that without even doing anything, look at this, positive y, negative y. Without doing anything, the y's will cancel. So in this case, the easiest way would be to use elimination. Alright, so I'm going to solve this. I'm going to eliminate the y's, and then remember what you do, you add the equations going down. So x plus x is 2x equals 34 plus 14 is 48. Divide both sides by 2, and x will be 24. Alright, now as always, so once we got one number, you're going to plug it back in to find the other variable. So I'm just going to plug this into the first equation. X plus y equals 34. Alright, so now we're going to do x plus y equals 34, but now x is 24, so I'm going to put 24 for the x, plus y equals 34. Solve for y by subtracting 24. And so that's gone, so now we're left with y equals 34 minus 24 is 10. Okay, so that means our two numbers, if I write them once again as a point, okay, I can say 24 comma 10. The first number was 24, the second number was 10. Okay, or in these kind of problems it's a little different, so let's say x equals 24, y equals 10, just another way to write the answer, but that's how you set it up. Okay, alright, let's try another one here. Number 2. The sum of two numbers is 8 less than twice the first number. Their difference is 4 less than twice the second number. Find each of the numbers. This problem is kind of like the first one because we're finding two numbers, but it's more complicated. Here's what's important. Sum of two numbers is 8 less than twice the first number. That's all one equation. Second equation, I'll use a different color. So second equation will be the difference is 4 less than twice the second number. Alright, so once again, we're going to use x and y. x will be the first number, y will be the second number. Alright, so first thing we're going to do is set up our system of equations. Okay? So, once again, sum means add. The sum of two numbers is. So look, that's the left side. The sum of two numbers is. So x plus y is, now this is going to be all on the right side. 8 less than twice the first number. Remember, less than is minus, but we also switch the order. So I'm not going to put the 8 first. Less than goes after. So 8 less than twice the first number. The first number is x. So twice the first number is 2x minus 8. This is 8 less than twice the first number. Alright, so to recap, this is the first sentence. The sum of two numbers is 8 less than twice the first number. Okay? Now we're going to go to the second one. The difference is, so look, difference and then is equal. So the left side is just the difference. X minus y equals. Well, it equals what? 4 less than. There's that less than again. Switch the order. Twice the second number. So look, now it's twice the second number, which is the y. 4 less than is minus 4. Okay, let me clean that up here. 2y minus 4. Alright, so here's our system. Okay, now I can't quite use this system because you'll notice these are not in standard form. I need to move all the x's and y's over. Okay, so this one, so we're going to have to rewrite it and change it. So x plus y equals 2x minus 8. So I need to get the x's over here. I'm going to do minus 2x to both sides. Those are gone. X minus 2x is negative x plus y equals, this is negative 8. Okay. Alright, so we've now made the first equation in standard form. Now we're going to do the second equation, which was x minus y equals 2y minus 4. So I'm going to move the y's over here by doing plus 2y. So it's going to be x, negative y plus 2y plus y equals negative 4. Alright, so let's rewrite these two equations so they look like a system, so we can look at them and see what the best way will be. Alright, so let's go back here. Alright, so now we have negative x plus y equals negative 8. And we have x plus y equals negative 4. Alright, once again, these came from the two equations after we changed them. So here's our system. Remember, we can use substitution, we can use elimination. But if we look here, hopefully you see, look, these are opposites. Negative x, positive x. So the quickest way will be to just combine them and eliminate the x's. So if I add up the equations now, the x's go away. Y plus y is 2y equals negative 8 minus 4 is negative 12. Divide both sides by 2. Y now equals negative 6. Alright, so I found my y. Now I need to find my x. Okay? So as always, I'm going to take what I have and I'm going to plug it in. I can plug this y equals negative 6 into one of the original equations or into one of the ones that I've changed. It's all the same. Okay? I'm just going to go ahead and plug it in to this second one. X plus y equals negative 4. So x plus y equals negative 4. I'm going to substitute negative 6 for y. So it's going to be x plus negative 6 equals negative 4. Alright, now the opposite of adding a negative 6 is subtracting a negative 6. You could do that another way too. But I'm going to subtract negative 6 from both sides. If I read it, negative 4 minus negative 6, minusing a negative is really adding. So negative 4 plus 6 is positive 2. Put into a point, x is 2, y is negative 6. Okay? So this is going to be the solution for both of these. Okay? Alright. Last equation here, or example. Now it says Mrs. Johnson is 3 times as old as her son. 10 years ago, she was 5 times as old as her son was then. Find each of their ages. Okay? So, this one, here's what's important. Mrs. Johnson is 3 times as old as her son. Alright? That's one important part. The other important part here is that 10 years ago, she was 5 times as old as her son was then. Okay? So we're going to find each of their ages. Okay? And instead of using x and y in this case, I'm going to use variables that kind of stand for the things in the problem. This kind of makes it a little easier to understand. Alright, so I'm going to use m. That's for Mrs. Johnson. Okay? So instead of x, I'm going to use m for Miss Johnson. And the other person is the son, so I'm going to use s for her son. Alright, this might make it a little bit easier to work with. Okay? Alright, so here's what it says. Miss Johnson is 3 times as old as her son. Miss Johnson is. So remember, Miss Johnson is the m. That means m equals this. So my first equation is going to be m equals, and then it's 3 times as old as her son. Well, her son is s, so 3 times s would be 3 times as old as her son. Miss Johnson is 3 times as old as her son. That's the first equation. Now it says, 10 years ago, she was 5 times as old as her son was then. So look, we need was and is kind of the same thing. Alright, so when we take this, oops, this is a mistake. So when we take this second sentence here, okay, what we're going to basically do is, so 10 years ago. So if this is how old she is, 10 years ago she was 10 years less, m minus 10 equals. Okay? Now this part's hard. 5 times as old as the son was then. So if we're talking about 10 years ago, it's not only is she 10 years younger, but the son's 10 years younger. Okay? So her son back then was s minus 10. But it's 5 times this. So we've got to put this in parentheses. So it's going to be set up like that. Okay? Now, hopefully you see now that the easiest method in this case would probably be substitution, because the variable is already by itself. M equals. I could just plug this in for m down here. Okay? So if we do that, so I'm going to take this second equation, m minus 10 equals 5 parentheses s minus 10. And I'm going to plug in 3s for m. So this m will be 3s minus 10 equals, I'm going to distribute 5s minus 50. Okay? Now I need to get my s's on both sides, so to move the 5s, I'm going to do minus 5s. 3s minus 5s is negative 2s. I got minus 10 equals, what's left here is negative 50. Alright, now to solve for s, we need to get the 10 moved over, so we're going to do plus 10. We have negative 2s equals negative 50 plus 10 is negative 40. Divide both sides by negative 2, and s will equal positive 20. So s is the son's age. That means the son is 20 years old. Okay? Now, once again, once you have one, you got to take this and plug it in. I'm going to plug it into this one because that's nice and easy. So if it's m equals 3s, and I know s equals 20, I'm just going to plug in 20 for s. So in this case, m is just 3 times 20, which is 60. Okay? So if I put that in the form of a point, once again, the first number was 60, Miss Johnson's age. Son's age was 20. Okay? So that is pretty much how you apply that. And a lot of it's just the setup and reading it. Once you got it set up, it's just substitution or elimination.